In this video, we're going to take a look at a web challenge that I made for INTIGRITI's Lead Up Live CTF 2024. It's called Cat Club, and this is what it looks like. You've got a cat gallery. These are my two cats when they were kittens, yin and yang. If you try to access the cat gallery, you'll see that it doesn't allow you to. You need to first register an account. So I'm going to do that, create an account called cat with the password cat. And now I can access this cat gallery, but there isn't much that you can do here. You can log out, you can go back to the gallery, go to the home page, and that is about it. So let's have a look at our cookies. I'm going to go into the storage, and you'll see here we've got a JWT. You can decode that with like a website like JWT.io or CyberChef, or you can use something like the JWT tool, which will take in a token like this and then just decode it so we can see that it's signed with an RS-256 algorithm, which is asymmetric. So it takes a private key and then it verifies with the public key. And then it has a username, which is set to cat, and that's about it. All right, I don't think there's much more to look at here. Let us just go over to the code. So this challenge also comes with the code so that you can have a look at it. And if we go in there, we can have a look at the Docker Compose first. So all of these values will change on the remote server, and that goes for the private key and the public key here as well. We have a Docker file. So if we want to find out where the flag is, you can see here that it's going to be moved to a random file name. So it's going to take 16 random characters and it's going to move it to /flag _ and then that random name. So that's where we're looking for the flag. And that is a hint that we're going to need to do something like a remote code execution so that we can execute commands on the server, or that we need to be able to read files somehow on the server as well. Maybe like a local file inclusion, something like that. In terms of our main application code, we can see we're probably going to want to have a look in this router.js, but I'm just going to check some of the other files first, as there's likely to be less code in them, or there might be. Router.js is likely to hold all of the routes, so it's probably more to go through. The sanitizer is taking in a username, and it's just making sure that it only contains letters and numbers, so that's worth bearing in mind. Let's actually go back and even test that out. If we go to log out, let's try and register a new account, and let us put in here cat club with an underscore, and again, and there you see that it didn't actually allow us to register because it can only contain letters and numbers. All right, worth knowing. And that might spark our interest, right? Because why are they limiting the characters that are being used in the username? Well, let's go back. Let's see what else we've got here. We've got models, which is going to be all of our database stuff. Nothing particularly interesting there. We've got our JWT helpers. So this is where the JWTs are signed with the private key, and then they are verified using the public key. And you can see there's also a check in here to make sure that the algorithm isn't set to none, because whenever you get a JWT, it's possible to modify it. But if we modify any of the values like this username, we're going to get an error because the signature is not going to be verified because we didn't re-sign it with this private key. But sometimes people are able to just change the algorithm in the header to none, and then it will just bypass verification altogether, meaning you could just change the username. So that is being checked for here as well. And that's about it. I think we've got some config, we've got our app.js where just the whole thing's starting from. And most importantly then, we have our router.js. We can go and have a look at the endpoints. First thing we'll notice is there is a JWK s.json, which will give us access to the public key. So let's go to this, JWK s.json. There we go, that recovers that. So that's the public key that's used for verifying the keys, but that's not much use to us, right? If we want to tamper with a token or generate our own, then we're going to need the private key to sign it. Having the public key just means that we can also verify whether a token was modified, and yeah, that's not going to help us here. So let's see what else we've got. We have a get current user function, which is going to verify the token and then get the username from that JWT. Then we've got our login and registration functionality, so it just takes the username and then it will hash the password as well. Down here, the user's being created, the JWT is being signed, and then we have the cat's endpoint, which will make sure that you're logged in first of all. We saw that at the beginning. And then it's going to render this template, which is cats.pug, which we can also go and have a look at in views. Nothing particularly interesting here, it just has those images that we saw. And it's going to render the template. It is going to look for a request.user, which is coming from this get current user function that we just looked at, right? It will take the JWT, it'll verify the signature, and then it'll grab the user from that. So it is taking that, and then it's going to replace the guest with that username. So if we go back to cats.pug, you see here it says welcome to the cat gallery guest. And if we go to the cat gallery, now that we're logged in, notice it says here, welcome to the cat gallery cat. So let's go back again. Pug.render. Well, this is a potential server-side template injection. This is being rendered using that pug library. And if we go to something like Hattrix, let's do Hattrix SSTI pug, we will find that there are some potential injections we can do here to execute code. Okay, I'm not seeing pug on the menu. Let me just do Control and F, and there we go. So yeah, if we do something like this as the username, it should actually render as 49 because it's going to execute this. And then we could then try things like this where we can create files, we can get a reverse shell maybe, or we can curl something back to our server, which would be nice. However, we can't do that because we can't add a username that has any special characters in it. We can only use letters and numbers, and that's not going to be enough to do any server-side template injection. So what do we need to do? Well, we've seen that there is a JWT being used. We know that we can't tamper with it. In fact, let me just try this. Let's take the JWT that we had. Let us go and do, let me do help because I forgot the menu options. But if we go to exploits here, you can see we can do like the none. We know that's not going to work, right? Because it specifically checks for none. But let's just see what happens if we just tamper. So if we do I to inject, and then we can set a claim. Let's just do it. Let's just do inject, and then the payload claim is the username, and then the payload value we want to change it to. And let's change it to, I don't know, let's just try and do an underscore just to see what happens. All right, so it gives us this token back. Let's just verify that it is actually updated. There we go. Yeah, it's set to a username. It's not set to a username, it's set to an underscore. So if we go back and take or if we just reload the page with that JWT, we will see that it has logged us out because it's not a valid one. And do I have, no, okay, I don't have any server login, but yeah, that's basically what happened. In fact, let me see, did Burp Suite come back with something? Okay, it redirected to login. It didn't come back with any error about the JWT. All right, that's fine anyway. We need to make sure it's signed properly, and this is where the other algorithm confusion attack comes in. I already mentioned that you could potentially set the algorithm to none. Well, we could also, now that we have access to the public key, what we could do is we could download the public key and then generate our own token or tamper with the token, sign it with that public key, and then change the algorithm from RS256 to HS256, because RS256 is that asymmetric algorithm we were talking about. It's going to sign with the private key. It's going to verify with the known public key. So this is secret, and then the other one is public. But if we change that to HS256, it is going to use a symmetric key. So it'll use the same key to sign as it uses to verify. So we change it to HS256, we sign it with the public key, and what's going to happen down here when it goes to verify? It's going to take the public key, which we use to sign it with, and then it's going to look at the algorithm and say, do I need to treat this as a public key, or do I need to treat it as a secret, like a HMAC? And it'll see HS256 and think, okay, this is a symmetric key, just use this to decrypt the token, basically. That should be enough for us to tamper with the tokens. I hope that made sense. I'm not too sure if I explained that very well, but we'll have a look at it in action here anyway. Now, I did already automate this somewhat. I have a solve script ready for this, and let me just show you how this works. It's going to register a new user. If one doesn't already exist, it's going to log in, and it's going to grab the JWT. It's also going to download the JWK, and then it's going to make a key from it, so it's going to turn it back into that PEM format, which is expected by the server side, and then it is going to modify it with the JWT tool. I was trying to use the script to do this, but I just couldn't get it working. It never gave me the same signature, and I was looking through the JWT tool code and trying to recreate it that way, but it just wasn't working. So I'm literally just calling the JWT tool, and then we extract the token that's going to come back from it, and then we can use that token as our new one. So this is the SSTI payload that I have set up. Let me actually just go, and we will take a basic one just to demonstrate this first of all. Let's go back here. All right, so this is what we're going to change the username to. Let's give it a go. Let me just do Python solve. All right, so let's see what it's doing. It registered a new user. It got the JWT. It downloaded the JWK. It made the public key, and then it saved that to recovered public key. We can also do a diff if we want to. Let's do a diff on that, and then on the public key. They both look the same, so you have to be careful here. If there's any difference in new lines or anything like that, or spaces, it won't work. And yeah, so it makes the key, and then it's going to modify the JWT. So here's the modified one, and then it sends that off. And somewhere in here, we should see, where is it printing? Welcome to the cat gallery. Oh, 49, there we go. I see it now. All right, so let's just do this. Let me just give that token that we just generated. So it's signed now. It's HS256. It's signed with a public key. This is the username. And if I take that now to the website, it's going to be the same, right? Because we just did it in the terminal, but oh, what? It's not the same. Home. Oh, there we go. Okay, it's because I'm still loading the login page. There we go. It is the same, and it's now printing 49, so we have that execution. So I'm going to go back. I'm just basically going to change this payload back to what it was. This is just a payload that I found on Hacktricks or on Payloads All the Things or something, which will execute some command, and I'm going to execute curl. I want to grab the flag. I don't know what it's called, but I know it's @ at the root directory, and I know it starts with flag, so we can just use a wildcard here. We won't get all of the special characters if we don't base64 encode it, so I'm just doing that as well. And then I've put in my attacker server here as well, which I need to launch. So let me just do a, I'll do, I don't think, do I actually need the web server set up? Maybe, let me do, all right, I'll do python-m http.server. We'll do it on port 1337, and then I will, now let's just create a new terminal. Let's do ngrok http 1337. This is going to expose my local 1337 HTTP server to this address. So if I now go here and just change this, paste that in, and let us now run the solve script again. Oh, I need to be in this virtual environment. Okay. I don't know if this is going to work. Let me see. All right, let's try it. Solve. Done. All right, looking good. Let's go back to our server log. You can see we've got this GET request, 200 OK. And here we go, back to our main server. You can see that the flag is in the server log. So I can just do now, echo that to a base64-D, decode it, and there we have the flag. I'm not sure if you could get some output here, because obviously we do get the output from this. I couldn't find any way. I think I did have this set to, I don't know. I couldn't find any way to get the output back on screen. I don't care if people solved it non-blind. Whenever I tried to solve it, I couldn't get it working without using curl or doing a reverse shell or something like that. So however you solve it is up to you. Anyway, I hope you enjoyed this challenge. This was, well, I did a challenge there a few weeks ago, which was basically the opposite of this. You had an SSTI vulnerability and a JWT algorithm confusion, but you needed to use the SSTI first in order to leak the public key and also leak some other variables on the server side. And then once you've done that, you were able to generate your own JWT. In this case, I've done the complete opposite. So in order to exploit the SSTI, you need to first do the algorithm confusion on the JWT. So I don't know, hopefully people thought it was interesting. And like the theme, these are my cats when they are grown up. So they're like 13 or 14 years old here and like 1 year old here. Anyway, hope you enjoyed this video. If you have any questions or comments, leave them down below. Thanks.